Okay, this is about mole fractions. So a mole fraction, and you should have your notes out, you should have a calculator, you should have your periodic table so that you can practice the problems while I am doing them. The mole fraction is the last way to find the concentration of something. So what we've been doing through all these videos is different ways to calculate the concentration. And mole fraction is the last way. So it's the ratio of the number of moles of the solute or the solvent, depending on which one you're talking about, to the total number of moles of the entire solution. So if you want to find the mole fraction of the solute, you take the moles of your solute and divide it by the moles of your total solution. And that'll give you an answer, and it'll tell you your mole fraction of just the solute. If you want to find the mole fraction of the solvent, you take the moles of your solvent, divide it by the moles of your solution again, and that will give you what the solvent's mole fraction is going to be. If you know one and not the other, you can easily figure out what the other one is going to be, because your mole fraction of your solute and the mole fraction of your solvent will always add up to 1. So that's an easy way to figure out what the other one's going to be. So let's practice a couple problems. It says, what is the mole fraction of sodium hydroxide in an aqueous solution that contains 22.8% sodium hydroxide by mass? So we learned earlier how to find the percent by mass. It's how much of the sodium hydroxide you have in your solution. So it's 22.8% sodium hydroxide. So for this problem, we want to find out what the mole fraction of the sodium hydroxide. That is your solute. So in order to do that, you need to take the moles of sodium hydroxide and divide it by the moles of the solution. Now it says up in the problem that we have an aqueous solution. So that means sodium hydroxide is dissolved in water. So we're going to say if I have 22.8%, that means I have 22.8 grams of sodium hydroxide. If you have 22.8%, how much water is in there? Well, everything has to add up to 100%. So 100 minus 22.8 means that you have 77.2% of the solution is water. So that means you have 77.2 grams of water. We did something similar to this when we had our empirical formula calculations. Remember, you take your percent, you change it to mass, you have to change your mass to moles. That's what we're going to have to do here in this problem. So it's similar, it's not the same calculations, but it's similar to that problem that we did with the empirical formulas. So according to our equation, we need to take moles of sodium hydroxide. I have grams, so that means we have to do some converting. So we'll take our 28 or 22.8, sorry, grams of sodium hydroxide times 1 mole over the gram formula mass. So here's where your periodic tables come in. You have to add up your gram formula mass for sodium hydroxide. So sodium is 23, oxygen 16, and hydrogen's 1. So that adds up to 40.0 grams of sodium hydroxide. And we get an answer. So 22.8 divided by 40 is 0.57 moles of sodium hydroxide. But we need to, according to our equation up here, we have to divide it by the moles of our solution. So we need to figure out how many moles of our solution we have. Okay, in this problem, it doesn't tell us how much total solution we have, but we just figured out how much water we have. So we're going to convert our 77.2 grams of water into moles of water. And the gram formula mass, you guys know of water, that water is 18. So when we do our math, 77.2 divided by 18, we get 4.28 moles of water. So back to our problem, we're taking our moles of our sodium hydroxide, which we know is 0.57, divided by our moles of solution. Well, a solution is made up of solute plus solvent. So we need to add these two numbers together. So when I add them together, 0.57 plus 4.28 is 4.85 moles of solution, total solution. So now I can go ahead and plug this in. I take my 0.57, and we need to actually put a 0 at the end there because we started with 3 sig figs. We got to end up with 3 sig figs. Moles divided by 4.85 moles. The moles are going to cancel. There are no units here. Okay, mole fraction has no units because they cancel out. So we end up with 0.118 as the mole fraction for the sodium hydroxide. Now, if I asked you what's the mole fraction of the water, there's two ways we can do it. We can take the moles of the water, which was the 4.28, divide it by the total, the 4.85, and figure out the mole fraction. Or you can take 1 minus your mole fraction of the sodium hydroxide and subtract them and get the mole fraction of the other one. So there's two ways that you can solve that: plugging it into the equation or subtracting from 1. Okay, one more problem we'll practice and then we'll be done. It says, what is the mole fraction of each component in a solution in which 3.57 grams of sodium chloride is dissolved in 25 grams of water? So this is almost exactly like the last problem that we did. Instead of starting with percentages, we're starting with our grams. So we need to change our grams into moles. So 23 plus 35.5 is 58.5. So we get 3.57 divided by 58.5. And your moles for this is 0.0610 moles of the sodium chloride. We'll do the same thing for the water. We got 25.0 grams of water. 1 mole over the gram formula mass, which is 18. So 25 divided by 18 is 1.39 moles of water. We need to add those together because we need our total solution. So 0.0610 plus 1.39 is 1.45 moles of total solution. So to figure out the mole fraction of the sodium chloride, we take the moles of the sodium chloride divide it by the total amount. The moles will cancel, so you have no unit. So 0.0610 divided by 1.45 is 0.0421. And then we can do the same thing for the water. We take the moles of the water, divide it by the total. the moles will cancel, so no unit. 1.39 divided by 1.45, and you get 0.959 for the mole fraction for the water. Now remember, another way that we can get the water, we can take 1 minus the mole fraction that we got for the sodium chlorides, which was 0.0421, and hopefully 1 minus 0.0421, we should get 0.95. How many places after the decimal do we need? That should be a 6. We'll round that up to a 6, which is pretty much the same answer. Why is there a difference? Because the sig figs are different between the two, but you got the same answer. So there's two ways that you can do it. You can find the mole fraction this way, or you can find the mole fraction of the water that way. So there's two different ways to do it. Once you have one, you can easily find out what the other one is by subtracting from 0.